Welcome to the Calsoft podcast series. This is your host Mark Rodrigues. I have with me today two very interesting gentlemen for a very interesting topic. Our topic for today is NFV for next gen wireless infrastructure, and with me I have Pawan Gupta. Hey Pawan, it's good to have you here.
Hi Mark.
We also have with us Ajit Vijayvargiya. Hey Ajit.
Yeah, hi Mark.
It's great to have you guys on the show.
Thanks, Mark.
Thanks Mark.
So before we get into today's topic, I'm going to quickly introduce these guys. So Pawan is a networking architect here with us at Calsoft. He has over 15 years of experience in the wireless networking, wireless telecom and embedded domain. He has, in the past, he's worked as a technical lead and architect for Cisco's mobile internet technology group, where he was responsible for design and development of LTE, 4G, EPC gateways such as S Gateway, EGW, SGW, GGSN and MME. Pawan was also responsible for building a cloud-based Wi-Fi solution for a tier 1 4G operator in India to provide Wi-Fi offload services to mobile subscribers at a Wi-Fi startup. It's a very interesting profile, Pawan.
Thanks.
Ajit is a senior technical lead here with us at Calsoft, and he has about 11 years of experience in the development, design and testing of enterprise LAN security product and cloud computing. He has an in-depth knowledge of the TCP IP protocol development, the DPDK development, virtualization and cloud computing. Ajit is a Red Hat certified engineer and also a certified cloud developer. So once again, Ajit, it's good to have you on the show too.
Thanks Mark.
So let's get into the overview of the topic. Pawan, you want to walk us through that?
Yeah, so today, Mark, we will be talking about network function virtualization of evolved packet core gateways and IP multimedia services. Both these networks are deployed by the mobile operators to provide data services and voice over LTE services to mobile subscribers. So presently, the present scenario is that these services, these network services, wherein a subscriber can log into 4G network and access the internet, this infrastructure is tied to proprietary hardware and software.
Correct.
And as a result, the 4G operators are tied down to a particular vendor, and at the same time they take very long cycles to deploy those services before they are made available to the users. This needs to change because the services are evolving and they need to be deployed at a faster rate. And network function virtualization is a way to achieve this. So as I said that the operators now want to move away from proprietary hardware to off-the-shelf hardware, and they also want to be selective about the software services they want to use. So they want to the present scenario is such that things become very monolithic. If they want to deploy a service, then they get tied down to a particular vendor. But with network function virtualization, they have the freedom to choose their own hardware and then choose their own software vendor. And then what they can do is you can chain these services from different vendors and achieve the same functionality. The advantage is that the operators have low capital expenditure and operational expenditure because they're using off-the-shelf hardware, and at the same time they have the freedom to choose the software vendors. With low barrier entry, it makes easier for many players to jump into this business, and it's very manageable to maintain the life cycle of the network services if you take the network function virtualization route. With the advent of virtualization, scalability of applications is much easier, and it is also easy to maintain the applications that are deployed for users.
Okay, thanks Pawan. So I don't want to indulge in hearsay, but what you're typically saying then is that for anybody to evolve their service line, they need to move towards NFV, correct?
So that's the next way going forward for the mobile operators. They want to be agile, they want to be fast and disruptive, and all this can be achieved if they have a framework that can help them achieve this. With network function virtualization, they can run independent network services at virtual network functions, and they can chain different services together and achieve the desired result. The present or the recent past scenario was that the services were monolithic in nature, and that made a little bit more difficult, a lot more difficult for the operators to deploy the whole service.
Okay, understood. Before we move ahead, what's a textbook or a very easily understandable definition of NFV?
Okay, it is NFV stands for, as I said, NFV stands for Network Function Virtualization.
Correct.
A very simple definition is you can break down your service functionality into different components and deploy them separately in a cloud-like environment and scale them as and when the requirement demands.
Okay, perfect. So I want to now move into the benefits of using the EPC NFV solutions and NFV. So you want to throw some light on that?
Yeah. So presently the EPC gateways, the Evolved Packet Core gateways such as MME, S Gateway, P Gateway, GGSN, they run on proprietary platform provided by companies like Cisco and Ericsson, Huawei's. They're very expensive platforms, monolithic in nature, and now with the advent of IoT and very high demand of 4G data services, it is required that these services be easily deployed. There also needs to be case for low capital expenditure, and there should be there needs to be an easy way to scale up and down as and when the demand is created.
Correct.
So NFV is going to help achieve all this.
Okay. So before we move into vIMS and vEPC, I want to tell our listeners that we are going to have right now Pawan and Ajit are going to be talking about our architecture diagrams. For our audio listeners, you can view this architecture diagrams on our YouTube page or our Calsoft or our website. Look at the links at the bottom of this podcast for further information on that. Okay. So now let's get into the architecture diagram of how this works, or broad level overview of how this works.
Yeah. So in this diagram, you can see that the diagram is split into three parts. One is the actual user who is basically owning the handset. That's the second part is the radio access network, which is actually the radio tower and the processing that is done for doing the radio processing, and then you have the IP backhaul network, which is the Evolved Packet Core network, where IP connectivity is provided to the mobile subscriber. And this is the part that we will be talking in this session. This is known as the Evolved Packet Core network, which consists of the home subscriber, server, mobility management entity, serving gateway, and P gateway. And there's also a policy engine known as PCRF. All of these services are presently or mostly deployed on proprietary hardware, and they're very expensive, as I said. But now all these functions are getting virtualized, and they would be chained to each other. And the operator now, with the help of virtualization, would be quickly able to deploy these services in his data center, and as and when the requirement spikes or goes down, he can manage it easily with the network function virtualization framework.
Okay.
At the same time, there is the IMS network, which runs separately, but it works in tandem with the Evolved Packet Core network. The vision of 4G was to make data and voice packet switch, so that the circuit switch network can be done away with. And to achieve that, they need a signaling network, which is provided by the IMS network. So both work in tandem. The 4G Evolved Packet Core network and the IMS network, they work in tandem to give voice services to mobile subscribers.
Okay, thanks, Pawan. So we're definitely going to be doing a huge and well extensive demo on how to set up these different nodes and how this works. But I want you guys to walk us through some print screens and a very high level overview of how this is. Would that be okay?
Sure, why not? So this is a 4G Evolved Packet Core network set up on a virtualized platform. We have used open air interface, open source code, for the different network services. As I said, HSS, MME, S gateway, and P gateway, and it's very easy to deploy these services. And with the help of a simulator, we were able to initiate a data session which would connect to the 4G network in a simulated mode. So there is no radio here, but the radio part is simulated, and it is connected to the 4G network. And once it is connected, then you could do some data transfer over the internet or through this demo. So there's a lot of effort happening in the open source world to make available these services to all, so that there can be more development, more innovation, and also the whole domain opens up for a lot of players.
So for our listeners who can see this, those 4 different boxes are the control planes, right?
Both the control and data plane.
Okay. And you managed to do an uplink and a downlink of data.
That's right. That's right.
Okay, perfect. Now I want to move into the vIMS part. Ajit, you want to take that? Firstly, what is the tool that you used?
So we have used Clearwater vIMS for this demo. Yeah, so Clearwater is an open source implementation of IMS, the IP multimedia subsystem, designed from the ground up for massively scalable deployment in the cloud to provide voice, video and messaging services to millions of the user.
Okay. So Ajit, you want to quickly walk us through the network architecture that we can see on the screen here?
Yes, so this is the Clearwater IMS network architecture diagram. So this architecture diagram has the various components required to implement a IMS solution for VoLTE service.
So Ajit, are you going to be throwing more light on those individual components and how that works?
Yes, Mark. So we will tackle that in our next demo.
Okay, will do. So Ajit, these screenshots that we've put up on the screen, now can you quickly walk us through those?
Yes, so this is the screens of Clearwater IMS. The first screen is the registration page. So whenever a user wants to do a call, IMS call, first he has to register with this page. User has to provide email ID and various other required parameter like password, etc. Then user will get a number. So in the third screen there is a SIP ID assigned to the user. Using that ID, that user can receive the calls, IMS calls.
Okay.
So this is the SIP client setting. The client which we have used is the Zyper client. Zyper is a very well known and widely used SIP client. So we have used the SIP client on a Windows machine, and this is the configuration required for the SIP client. So as you can see that there is a number which we got when user registered on the portal. User gets a number. This number is provided here, and based on that user can register his device on the SIP server.
Okay.
Yeah, this two screen shows the one screen is showing that whenever a other user call this user, there is a notification on the screen which says that there is a incoming call. And the second screen shows that the when this user calls another user, it will show you that the call gets established.
So how to do all of this? You're going to, the setup of this will be in the demo, right?
Yeah. So in the next demo, what we are planning to do, we will deploy this Clearwater vIMS solution in the cloud. We will provide ability to users to set up a vIMS call between two geographic locations.
Okay, perfect. We look forward to that. So now we've spoken about the EPC NFV solution and NFV in totality, and we've also looked at the different components of this. Now I want to tackle a very different aspect, Pawan. Now I want to look at how this ties into day-to-day business offerings, right? So I want to take this one by one. The first thing I want to look at is what is the basic offering to NFV vendors?
So for a company like Calsoft, we have the depth and the expertise to build the virtual network functions which would fit into the NVF framework. And that includes building services like the EPC gateways we just talked about, And there are other aspects which can run as virtual network functions, like firewalls, NATing service, content filtering, deep packet inspection, and many other things that that can possibly happen. So anyone interested in building virtual network functions, Calsoft is ideally poised. They have the skill and the talent and expertise to provide engineering services to those interested people.
Okay, if somebody were to do an NFV validation, firstly, what is the business case for doing that?
So there are myriad of components involved in setting up an NFV environment, and that includes things like setting up the cloud using OpenStack, chaining the services, using virtual network functions from different vendors, and then interoperating all of them together by means of chaining. All of this requires a lot of dedicated effort and expertise to make it happen successful. And a service provider like us is able to do that, wherein we can pull in different components to set up the network function virtualization system, and we kind of go through the whole system, make it work, chain it together, and ensure that the whole system is validated before it can be deployed live. So let me give you an example. If you want to deploy the 4G Evolved Packet Core services into the cloud, then there are a lot of things that go into to make it happen, and there are tons of or there are multiple services that are required to run together, and they also need to talk to each other. A lot of benchmark testing, performance testing needs to happen before you can actually certify it to be live, and that's what we are good at doing.
Okay, so that's the business case for NFV validation. Right now, there are two aspects to this. One is why would telcos do it, and the other aspect is why would hardware vendors do this. So you want to look at the aspect of why the telco should get into an NFV validation.
Yeah, the telcos want to ensure that whatever they deploy, is going to work for them. It's a lot of investment and time, energy to actually make things work together in a telco data center. And if a service provider like us can do it, using our expertise and experience, then it would be a lot easier for them to know that a certain solution would work at a much or can be deployed at a much faster pace.
So essentially, we're helping expedite service offerings or service lines to their end customers.
Yeah, you can say that. We are helping them to achieve their goal. Telco's goal is actually to offer services to subscribers.
Correct.
and we want to help them by taking away, by helping them to focus on what they are good at, and by doing good or doing what we are good at, we would help them expedite the whole thing much faster.
Okay, I want to step away from this podcast and ask you a very generic question. Are any telcos, without obviously naming them, but are any of these telcos already on this journey of NFV?
Oh yeah, absolutely. The telcos in the US are gearing up for this. Players have already started thinking, and I'm way deep into that thought process. And this is a natural progression for all the telcos. Eventually, in the next few years, they are going to move to NFV platform because they want to make their life easier. They want to focus more on giving good services to their subscribers. So just think about it. You have the Amazon Web Services for providing for running a software on cloud.
Correct.
Now this is the AWS for telcos. NFV is the AWS for telcos.
Okay. And while I want to chew your brains about the 4G network, what about the 5G? It's obviously that's a natural progression. How does this play a part in that? Or is it too early to say?
No, NFV plays a very, very important role as a part of 5G service offering. With the advent of IoT, you're going to need millions of devices are going to get onto the internet to share data, and you are going to need a lot of these services and you would have to scale them as and when the demand is spiked. So NFV is going to play a very, very crucial role when it comes to 5G. In fact, it is one of the critical components of 5G networks.
Okay, understood. So we've spoken about the validation for telcos. My other question was the validation for hardware vendors. How does that work?
So the hardware vendors, in addition to selling their hardware, they also want to sell the solution, wherein they want to pull in components from different vendors, deploy them on their hardware, and make them work together. Now, this is an exercise in itself. It's a big activity, a big effort, and all of this needs people with deep expertise, and that's what a service provider like us can do.
So would you say this is like a natural progression from like bare metal to software defined everything?
Absolutely, yes. That's where the networking industry is heading, and everybody would be going in that direction sooner or later.
Okay, perfect. And lastly, you mentioned IoT a few times in this podcast now. So you want to throw some more light on how NFV is tying into that aspect?
Yeah, IoT is such a wide domain that it's going to infiltrate everywhere, right from having devices embedded under your skin to using devices in industries, machines, remote areas. So the nature of IoT devices is going to be diverse, and because of this diversity, you would need different kind of services, different functionalities, and not one vendor can do that. So with NFV, an operator would have the freedom to pick and choose services based on the service offering they have, and for them it would be easy to support the different demands for IoT devices.
On a fundamental level, would you say that NFV is growing at the same pace as IoT?
Yeah, you can say that. The world is geared for IoT, and at the same time, the telecom vendors or the telecom operators are gearing up for NFV to make the marriage happen.
Okay, brilliant. So we look forward to the demo that you guys are going to do on the use of vIMS and vEPC. That sounds very interesting. The screenshot looks very, very interesting.
Sure, Mark.
Sure, Mark.
So that ends our podcast for today. As reminded earlier, for our audio listeners that want to look at the architecture diagrams, you may refer our YouTube or our website. If you have any questions for us, or if you would like to have a demo set up for your team, write to us at marketing@calsoftinc.com. Thank you and have a great day. Bye-bye.